Hi, so we're going to devote this entire video just on the chain rule because it is that important. So now we've picked up a lot of different rules and techniques on how to do derivatives the short way and not use this long difference quotient that takes up way too much time, especially on a test. So we learned the product rule, the power rule. So let's do a mini review. So power rule states that d dx of x to the n is equal to nx to the n minus 1, right? Product rule is d dx of u times v is equal to uv prime plus vu prime. And the quotient rule says that the derivative d dx of u over v is going to be equal to vu prime minus uv prime over v squared. So that's our mini review. And now we're going to learn the chain rule. So we're going to stop using u and v here because it's going to get confusing if we do. And we're going to go back to our u equals f of x and v equals g of x notation here. So the chain rule, say I want to find the derivative d dx of f of x, well, f of g of x. So f of g of x. So it's a composition of two functions. And if you really insist on writing this in u and v notation, this is the same thing as saying d dx of f dot g, because we do g first and then we apply f. So the chain rule states that this derivative is equal to f prime of g of x times g prime of x. And this might take a while to stomach and mull over and finally understand, but I think it's best to explain the chain rule using an example. And the example I'm going to use is a pretty simple one. It's going to be d dx of sine of 5x. And you may say this is cosine of 5x, but actually you would be wrong. It looks like it might be, but that is just treating this 5x as if it was just x, which it's not. It's not just x, it's 5x. So the hardest part about the chain rule is identifying what's f of x and what's g of x. And I don't think it's that hard in this case. We can determine that f of x is equal to sine of x. And I think we can determine that g of x is equal to 5x. So when we apply the chain rule, we first have to find the derivative of this f of x, right? But instead of x, we're going to replace the x's that we see with g of x. So in f of x, we have sine of x, right? But now instead of x, we're going to replace this x with g of x, which is 5x. So you'll see what I mean. The derivative of sine x is cosine x, but f prime of g of x is going to be cosine of 5x, because we're replacing this x by 5x, right? And now if we're multiplying by just g prime of x, well, what's g prime of x? Well, g prime of x is just 5, right? Because the derivative of 5x is 5 using the power rule. So now we just have to multiply these two together to get 5 cosine of 5x. And that's our derivative. Don't worry, we're going to spend this entire video doing examples just on the chain rule, just so that it becomes clearer. Here's another Here's another common question that they might give you. What is 4x cubed plus 2x to the fifth? Now this is interesting because technically you can FOIL this out and just not use the chain rule, but it would take an absurdly long amount of time and it's quite inefficient. So what you can use instead is use the chain rule. That's a 3, by the way. So f of x is usually going to be whatever is the most outside function. And in this case, that's going to be x to the fifth. So f of x is equal to x to the fifth. And g of x, well, on that assumption, g of x has to be 4x cubed plus 2x. So now the chain rule states that the derivative of f of g of x is equal to f prime of g of x times g prime of x. The derivative of the outside and keep the inside, but then multiply by the derivative of the inside. So what is f prime of g of x? Well, f prime of just x is going to be 5x to the fourth, so let me write that down. F prime of x is equal to 5x to the fourth. So f prime of g of x is going to be this, but instead of this x, we're going to replace it by 4x cubed plus 2x, which is g. So it's 5 times 4x cubed plus 2x to the fourth. Now what's g prime of x? Well, we just use our power rules. The derivative of 4x cubed, it's 3 times 4x, which is 12x. We decrement the power by 1, that's 2. And then we add plus 2x. Well, the derivative of 2x is just 2. So now we have our answer. The derivative of 4x cubed plus 2x to the fifth is going to be 5 times 4x cubed plus 2x, all of that to the fourth, times 12x squared plus 2. And yes, this can be simplified, but it's okay if you decide not to. This is a perfectly fine form. And it shows that you did the chain rule. Now I'm just going to do one last example, and this is going to use multiple chain rules just so that you can really understand what the chain rule is all about. So I want to find the derivative of sine of x. So you may be saying, what the actual heck are you talking about? Well, let's just go through it step by step. What is the most outside function here? Well, this is the most outside function, sine of x. So f of x is going to equal sine of x, and g of x is going to equal what? This whole inside is g of x. So that's sine of x. And what does the chain rule tell us? Well, the chain rule tells us that this derivative is going to be equal to f prime of g of x. So what's f prime of x? So f prime of x is equal to cosine x. And f prime of g of x is going to be cosine of this inside here, which is sine of x. So this is going to be equal to cosine of sine of x, like so. And we're going to multiply this by g prime of x. Well, what's g prime of x? Well, we can't really determine that right away. We actually have to do another chain rule. So what's g prime of x? Well, to break this up, we have to make another chain rule. So I'm going to call this green the outside portion of g of x. And so I'm going to call that h of x. So h of x is equal to sine of x. And then the inside here, I'm going to call j of x because I'm running out of letters. So j of x is equal to sine x also. So this whole calculation here is going to be g prime of x. And to do it, we're doing another chain rule. So g prime of x, or the derivative of sine of x, is going to be h prime of x, which is cosine x. But instead of x, we're going to replace it by this whole inside here, which is sine of x. So it's cosine of sine of x times the derivative of j of x, which is cosine of x. So this whole thing here is going to be the derivative of g of x. So cosine of sine of x times cosine of x. And we're done. This is, in fact, our entire derivative. So that's kind of cool, isn't it? Oops. And you know, it looks almost like a pattern. You have a cosine of two layered sines times a cosine of just one sine, and then multiplied by a cosine with no sines. It's just x.